Guys, welcome back to the channel. So in this video we'll see an important question based on stack, that is how to sort a stack. So we have given us input stack. In random fashion, integers are given in the input stack, so we have to sort this particular stack so that our output stack will look like this, so that all the elements are in increasing order. Right now you can see this. Okay, so first I'll recommend you to pause the video and think and try to build the logic of this particular question, that is how to sort a stack, then come to watch this video. Okay, so that your mind will get work. Okay, so let's just see how we can do this. To solve this, we will use an extra space called temporary stack, in which we'll store our sorted stack in a linear increasing fashion. So at the very first, we'll check our temporary stack is empty or not. So temporary stack is empty right now, so we'll pop an element from the input stack and we'll push it into the temporary stack. Now again we'll pop an element from the input stack, that is 92, and again, but now our temporary stack is not empty, so we'll check if our popped element is greater than the top of the temporary stack or not. So 92 is greater than temporary top of the temporary stack, so 92 will be pushed. Then again we'll pop an element from the input stack, that is 98, and again we'll check with the top of the stack. So 98 is again greater than 92, so we'll push 92 again. Now we'll pop 31 and we'll check with the top of the temporary stack. So 31 is not greater than 98, that is top of the temporary stack, so we'll not push it right now. Rather than, we'll just pop greater element than 31 from the temporary stack. So 98 and 92 is greater than 31, so we'll pop it from the temporary stack and we'll push it back into the input stack. So 98 and 92 will be pushed back into the input stack. Now 31 can be inserted, so 31 is now pushed into the temporary stack. Then again we'll pop an element from the input stack, so 92 will be pop, and again we'll check with the top of the temporary stack. Now our top is at 31. Okay, so 92 is greater than 31, so we'll push it into the temporary stack. Then again we'll pop 98, and 98 is also greater than top of the temporary stack, so again 98 will be pushed. Now we'll pop an element 3 from the input stack, and again we'll check with the 98, that is top of the temporary stack. So 3 is not greater than 98, so we'll not push it into the temporary stack. Rather than, we'll just pop those greater element than 3. So all these elements are greater than 3, so we'll pop this element and we'll push back into the temporary stack. So 98, 92, 31 and 23 will be popped from the temporary stack and will push back into the input stack. Now 3 can be inserted into the temporary stack. Now 3 is inserted, that is 3 is now the top of the temporary stack. Then again we'll pop the top element, that is 23. So 23 is greater than top of the temporary stack, that is 3, so we'll insert it. Then again we'll pop 31, so 31 is also greater than top of the temporary stack, so we'll push it. Then again 92, so 92 is also greater than top of the temporary stack, so we'll push it. Then again we'll pop 98, so 98 is also greater than top of the temporary stack, so 98 will be pushed again. Then again we'll pop 34, so 34 is not greater than top of the temporary stack, so we'll not push it. Rather than, we'll just pop those greater element than 34. So 98, 92 will be popped from the temporary stack and will push back into the input stack. So 98, 92 will be popped from the temporary stack, will push it into the input stack. So now 98 and 92 will be popped, and now we can insert 34. So 34 can be inserted into the temporary stack. So again we'll now the top of the input stack is 92. So 92 will check is the popped element, that is 92, is greater than the top of the stack or not, and temporary stack or not. So the top of the temporary stack is now 34. So 92 is greater than 34. So we'll just push it into the temporary stack. Then again we'll pop 98 from the input stack and we'll check it with the top of the temporary stack. So 98 is also greater than top of the temporary stack, that is 92. So we'll push it. Now our temporary stack will be look like this, that is 3, then 23, then 31, then 34, then 92, and then 98. So as you can see that our input stack is sorted with the help of temporary stack, that is by using extra space. So let's just see the pseudocode for this. Here I will be discussing with you Java code. Okay, so here I have initialized the function called sort stack, which will be returning a stack, and here I have taken an argument from the main function, that is input stack. Now here I have initialized a temporary stack where we'll be storing our sorted stack, and we'll check is our input stack is empty or not. So if it's not empty, we'll just pop an element from the input stack and we'll store it into the temporary variable. Then again we'll check if our top of the stack input stack is greater than the top of the temporary stack. So if it's greater, so we'll just push it into the temporary stack. So if it's not greater, if our top of the temporary stack is greater, so we'll just pop the element one by one from the temporary stack and we'll push it back into the input stack, and at last we'll be returning our temporary stack, that is our sorted stack. Okay, so that is the Java code. So let's just discuss the time complexity of this will be O of n square, and the space complexity will remain O of n because we are using an extra space here. Okay, so hope you like this video. Make sure you like, share and subscribe to the channel. So till then, bye. I'll see you in the next video.